is a parallelogram. The reason I say the hot mess continues is, you know how right before break, you're like getting things done, and you think you're doing a great job, and then you come back and realize, nah, this is the front of your notes, at least the top section. So I'm going to tell you how to correct it. If you have whiteout, that'd be a great time to use it. Dr. Kinder says that we don't need whiteout anymore, but everyone makes mistakes, including me. So, the top number 1 is fine. You got opposite sides, and then a little arrow. It's cool. Leave that. That's great. It's golden. Number 2, opposite angles. You know, I ain't even mad about that. That's good. It's totally fine. Diagonals, leave it. It's fine. 4. Really should be 2 things, and neither of them are consecutive angles. It should be opposite sides, and number 5, though it seems redundant, should also be opposite sides. So if you want to make room, make it work, whatever. This is what it's supposed to look like, so I apologize again. So there are 5 ways to prove that a quadrilateral is a parallelogram. So you're going to fill in your notes at the very top. I probably just said that. I paused. I'm sorry. Some kid lost his cat in a tree. It is what it is. All right, here we go. So the first one would be show that one pair of opposite sides are congruent and parallel. So at the top where it says 1, opposite sides, so I would write on the left half of the and sign that they are congruent, and on the right half of the and sign, you'd write that they're parallel. So opposite sides are congruent and parallel. Opposite angles are congruent. This is not new information. This is number 2 on your paper. This is number 3 on mine. Diagonals bisect each other. And then this is again redundant, but it is what it is. It's in the book. These highly intellectual people decided it really needed 2 other lines, but the next, on number 4, where it says opposite angles, or opposite sides are parallel. And then number 5, opposite sides are congruent. So even though these are literally saying the same thing, if it doesn't have or doesn't show that they're both congruent and parallel, the fact that they're parallel or congruent is enough. So you don't have to have opposite sides both congruent and parallel. They could just be parallel or they could just be congruent, and that would still be enough information to prove that a quadrilateral is a parallelogram. So we're going to move on from that. This is not really new information. We've done problems like these before in 7.2. For what values of x and y is quadrilateral PQRS a parallelogram? Basically, you use the properties that would prove that this is a parallelogram. One of them would be that opposite sides are congruent. So PS and QR would need to be congruent. But if I set them equal, y equals x plus 7, they do technically equal. This does not help me at all. I got a y on this side, I got an x on that side, it ain't gonna help. I can look at the other pair of sides. In order for this parallelogram to be parallel, this side would have to be congruent to this side as well. So if they were, they would equal. So I could take x plus 9, and it would have to equal 2x minus 1. If that's the case, I can definitely find the value of x, subtract my smaller x, I get 9 equals x minus 1, add 1, and 10 equals x. So I've answered half of the problem. I found the value of x. The only place I see a y is in this equation, in this side. So what we can do is, if we know what x is, we can plug it right on in. So we're going to keep our y equals 10 plus 7. So I plugged in my x that I found down here. I plugged it in. So y has to equal 17. Ta-da! That's it. So the second, this is kind of like a explain question, not really any math. The doorway shown is part of a building in England. Over time, the building has leaned sideways. Explain how you know SV is equal to TU. It's actually saying SV as in the length of SV and the length of TU are going to be congruent. So what I notice is that there's a triangle and a line. Now I know that you millennials, or whatever generation you are, this looks like a play or stop symbol. I don't know. I never understood it. But anyways, it looks like that, but it's not. Remember that the triangles on a line mean that they're parallel. So these opposite sides are parallel, and remember that dash means that they're congruent. So if ST and VU are parallel and congruent, this is more than enough information to prove that we have a parallelogram. So then SV would have to be congruent to TU. So our reasoning is, because ST and these lines, remember, that's ugly. This line, or these twin towers I call them, mean that they're parallel. So because ST and UV are parallel, also because ST is congruent to UV because of the little lines, by the opposite sides, parallel and congruent theorem, quadrilateral STUV is a parallelogram. So did I answer the question? Did I explain how I know that SV is equal to TU? I did not. So the last part is by the parallelogram opposite sides theorem. So because this is a parallelogram, that means the opposite sides have to be congruent. So SV has to be equal to TU. The length of SV has to be equal to the length of TU. All right, we flip. For what value of x is quadrilateral CDEF a parallelogram, and explain? So if you notice, the information that we're given are these lines. These are diagonals. Diagonals go from one vertice to a non-consecutive vertice. So these diagonals are also, it appears, at least this one, CE, is cut in half. So there is a property, it's the third one on your list, because your diagonals bisect each other. This is a parallelogram. Parallel. So because of this, that means the other diagonal, Fn, has to be congruent to Dn. So 5x minus 8 has to be equal to 3x. So we can solve. Normally I move the smaller x. A lot of you make a mistake when you do this. It's fine to move this smaller x. However, when you do this, the right side doesn't completely go away. 3x minus 3x is 0. So you can't just forget about it. 5x minus 3x is 2x, minus 8. Add 8. Oop, that's ugly. Add 8. 2x equals 8. Our last step will be dividing by 2. Divide by 2. And x equals 4. Almost finished. In exercises 1 through 3, state which theorem you can use to show that the quadrilateral is a parallelogram. So in number 1, all we're given is this is an A and this is an A. Because they're the same letter, that means they are the same length. Also, we're given this triangle. Remember, this triangle means that they're parallel. So because of this, this is a theorem. This is the one that I find a little bit redundant, but it is the opposite sides parallel and congruent theorem. Here's what I would accept from you come the day of the test, the day of the quiz or whatever. If you just told me that the opposite sides were congruent and parallel, I would take that. If you want to memorize the name of the theorems, that is also acceptable. Either way. In number 2, you're given angles. There's only one theorem that proves that angles are congruent if you take a look at the front of your notes. And it is that opposite angles are congruent, which here they are indeed. So because of this, the theorem that proves it is opposite angles. So again, if you told me opposite angles are congruent, I would accept that. You don't have to know the theorem. And then number 3, I see we have lines that have these dashes that show that they're congruent. These are the diagonals because they go from one vertex to the other, one vertex to the other. The diagonals clearly bisect each other because when this orange one goes through the black one, or whatever you want to call it, it cuts it perfectly in half. Also, when this blue one cuts through the other one, it cuts that diagonal perfectly in half. So because of this, diagonals, it's called the diagonals converse. I again would say if you told me that the diagonals were bisected, it's more than enough information for me. We got 2 more problems and we are finished. Find the values of x and y that make the quadrilateral a parallelogram. So a lot of us know that opposite angles are congruent. So we know 3x minus 20 will equal 4y. But again, this does not help me. I have an x and I have a y. I see that I have an x here and I have an x here. So I need to find the relationship between these 2 angles. If you recall from 7.2, you remember that these are called consecutive angles. And consecutive angles are supplementary. Supplementary means they add up to 180. So we can do this to start our problem. So I can take 3x minus 20, which is the left angle. I'm going to add it to x plus 40, and it will equal 180 degrees because they're consecutive. So 3x and x make 4x. Minus 20 plus 40 is plus 20 equals 180. Continue our math. Subtract 20. 4x equals 160. To finish the problem, we are going to divide by 4 if I have enough room. Nope. Divide by 4 on both sides. Divide by 4, divide by 4. So x equals 40. So I found x. I need to find y. The way to find y is to plug x back in. So I'm going to plug it in here. I'm also going to move this guy up. So we'll have 3 times my x, which was 40. And then everything else will stay the same. Minus 20 equals 4y. So we'll have 3 times 40, which is 120, minus 20 equals 4y. I'm going to make this bottom section smaller now. I'm going to add 20. Oh, no, I'm not. What am I thinking? Who am I? 120 minus 20 is 100. Hello. Equals 4y. Divide by 4. Divide by 4. And y equals 25. Sorry, it's not the prettiest. I'm trying to make it quicker. In number, whatever this is, number 5, again, we see that they're pointing these lines. These are the diagonals. So the diagonals are going to equal each other because it's bisected. So 2y is going to equal y plus 1. Subtract y. Y equals 1. That was simple enough. Do the same thing with the x's, it appears. My diagonal here, my diagonal here. They will equal each other. 6x equals 4x plus 10. Move my smaller x. 2x equals 10. X equals 5. Alright guys, that is it for our notes. Make sure you do your review sections. This is my TED Talk. Have a great night.